Good evening, class 9. So this lecture is going for you. Chapter number 1, motion was going on and it was almost completed. Numericals were left. That is why I am going to create this video for telling you more about the numericals, and we will discuss only the numericals in this particular lecture. So let us begin. I will write the questions so that you will be able to understand the question as well as the solution. So the very first question which I am going to explain you, Rita takes 20 minutes to cover a distance of 3.2 kilometers on a bicycle. Okay, calculate her speed. Calculate her speed in kilometer per minute and meter per minute. So they have asked the answer in 2 units. Fine. So time is given to us, that is 20 minutes, and distance is given to us, that is 3.2 kilometers. So let us write what are given to us. Distance is 3.2 kilometers. They are asking the answer in kilometer as well. So let us write this in kilometer. If this will be required in meter, then this will be how much? For alternative I am writing 1 kilometer is equal to 1000 meter. So 3.2 kilometer is equal to 3.2 into 1000. That will be 3200 meter. If this will be required, we will take the data in meter. If in kilometer is required, we will take the data in kilometer. And now, what is the time given to us? Time is given 20 minutes. Time is required in minute only. As you can see, the answer which is asked is in kilometer per minute or meter per minute. So time we don't need to change. Now students, let us apply the formula. Speed is equal to distance upon time. So that's a very simple numerical. Distance, let us substitute distance 3.2 upon time 20. So how to solve this? This will be 1.6 if we divide it by 2 upon 10. So this will be 1.6 upon 10. Point will be shifted out. So this will be 0.16 kilometer per minute. So this is when we have solved for kilometer per minute. But they have asked in meter per minute as well. So this will be how much? Speed will be 3200, that is in meter, divided by minute. How much minutes are there? 20 minutes. So solve this. 2 16 times, so 160 meter per minute. So students, we have solved it for both the units. That was only asked. So I hope you understood this numerical. Just a formula based numerical. Okay. Now students, second question. A car travels the first 20 kilometer, the first 20 kilometer with a speed of with a speed of 40 kilometer per hour, and the next 40 kilometer in the next 40 kilometer with a speed of 80 kilometer per hour. Find the average speed. Find the average speed. So students, whatever thing is asked to us, we should be aware about the formula first. Our mind should be working that what is the formula for that. So what is the formula for average speed? The formula for average speed is total distance upon total time. So students, for calculating average speed, we should be aware about two things. One is total distance, another total time. So car travel the first 20 km with a speed of 40 and next 40 km with a speed of 80. We should picturize this. Okay, so let us make a diagram to understand this. Suppose there is a point A, there is a point B. So what is happening actually? First 20 kilometers. First 20 kilometers. So this is 20 kilometers. What is the speed of the car? Let us draw the RSM. Okay. So the speed of the car for first 20 kilometers is 40 kilometers per hour. Fine. In the next 40 kilometers, so this is the next 40 kilometers. The speed is 80 kilometers per hour. So suppose this point is D. From this point, the car speed is 80 kilometers per hour. So students, as the formula is total distance, what is the total distance? We are aware about 20 plus 40. So total distance is 60 kilometers. But total time we don't know. Actually, we don't know the separate time. So let us calculate the time. What is the formula for time? If the formula for speed is distance upon time, if the formula for speed is distance upon time, then by the same formula, by cross multiply, the formula for time will be distance upon speed. So roughly we can remember this by this method. Okay. So distance upon speed. So firstly calculate time taken by car to travel. How much initially it has traveled? 20 kilometers. To travel first 20 kilometers, that is denoted by T1. T1 is equal to distance upon speed. So what is the distance? 20. And what is the speed? 40. Okay. So 20 upon 40, 0 and 0 cancel out. 1 upon 2 or 0.5 r. This was in kilometer per hour, in kilometer. So 0.5 r. Now, similarly, calculate the time taken by car to travel 40 kilometer further. Okay, 40 kilometer. So this will be denoted by T2 is equal to distance upon speed. What is the distance? 40. And what is the speed? That is 80. So 40 upon 80, that is also 1 upon 2 or 0.5 r. Now apply the formula for average speed. Average speed formula we already know. Total distance, and that is total distance is 60 kilometer upon total time. Total time will be 0.5 plus 0.5. Okay, so this will be 60 upon 0.5 plus 0.5 1. So this will be 60, and this is the speed. So this will be kilometer per hour. Okay, I hope you understood this. Let me check the answer. So it's correct. 60 km per hour. I hope you understood this. So let us solve another numericals. So students, the next numerical which I have considered, we are going to solve is a uh, train covers half of its journey, half of its journey with a speed of with a speed of the other half and the other half with a speed of with a speed of 40 meter per second. Calculate calculate the average speed. Calculate the average speed during the whole journey. During the whole journey. So let us solve this question. Question I have written. And whenever you are solving a question in physics, it's really important to actually picturize it, visualize it. Okay, that's why we draw the figure. So a train covers half of its journey. So let us draw a figure. Half of the journey. Suppose the total journey is S, because we don't know that how much journey it have traveled. So I am taking it S. So there is a point A and there is a point B. The distance between the two points is S. So what will be the half? Suppose this point is D and total is S. So this will be S upon 2. Half will be. Similarly, this also will be S upon 2. So half of the journey is traveled with the speed of 30 meter per second. So speed we know that is 30 meter per second for this much from A to B. Okay, and when it traveled from other half, the speed is 40 meter per second. So for D to B, the speed will become 40 meter per second. We have to calculate the average speed. So students, whenever we are calculating average speed, then we should be aware about one thing, that is total distance, and another thing, that is total time. So total distance we all know. We can see that is S. So S upon 2, S upon 2 we have broken out. So total distance is S only. Or if you want to ease your calculation, I can tell you one more. You can assume this is 2S, then half journey will be S, another half journey will be S. So it's about you, howsoever you will feel convenient. You can solve it for S and S by 2, S by 2 as well. For making your calculation easier, because everyone is taking care about points, decimal S upon 2, that's why I have given it to us. So total distance is given to us, total time. So time we will calculate firstly from A to D. Okay, time taken by train from A to B. So we can write it journey from A to B. Okay, journey from A to B or A to D. So that is the point D. So A to D. That is denoted by T1. So T1 is equal to, the formula for time is distance upon speed. So what is the distance traveled by the train, that is S, and what is the speed? Speed is given to us, that is 30. So S upon 30, we have assumed it in meter. Okay. So, and this is in meter per second. So this time will be in second. Okay. Don't be confused and by S and second. That's why I have written properly second. So let us calculate the another time taken by train from D to B. So what is the time taken by train from T to B? This will be equal to, that is denoted by T2. So T2 is equal to, distance is S only, distance upon speed. Speed is 40. So this is in second. So students, we have the time, we have the distance. In the formula for average speed, total distance upon total time. I am writing in short, but you are not allowed to write during the class or during the answers when you will mention. You will write properly. Average speed formula, distance upon total time. So total distance is how much? 2s. And what is the total time? That is s upon 30 means t1 plus t2, s upon 40. So students, if you feel little trouble with how to solve all this, so you can imagine upon 1, and here you can take out the main bracket. Okay, main fraction. So let us solve this. So 2s upon 1 divided by 30 and 40. LCM will be how much? 120. So 30 4s are, so 4s plus 40 3s are, so 3s. So when this bracket will be solved, 2s upon 1 into this will come in the reciprocal 120 divided by 4s plus 3s. This will be 7s. S and S gets cancel out. So 122 are 3 quarters, sorry, 240 divided by 7. So divide this. 7 3 is 21. 3 moves there. So 7 4 is 28. 2 is there. 7 3 is 21. It's little greater. So we can take this much approximation. That is allowed. Okay, so 34.3. This is answer is in which unit? So we should be well aware about in which unit it was given to us meter per second. So average speed is 34.3 meter per second. So students, this is how smartly we can solve. Even the distance wasn't mentioned to us. So we assumed it smartly and we had solved. I hope that you understood this. Okay. So we are going to solve another numericals. Okay. So students, we are going to solve another numericals. Now the question which we are going to solve, a bus accelerates uniformly from 18 km per hour from 18 km per hour to 36 km per hour in 10 seconds. Calculate the acceleration. So students, you all are aware about the formula for acceleration. So acceleration is change in velocity upon time taken. So a bus accelerates uniformly from 18 km per hour. So the question is starting with the bus with a speed of 18 km per hour. So this 18 km per hour will be taken as initial velocity. Okay, you can write it properly. Initial velocity of bus. What is it? 18 km per hour. In students, already in the class we have discussed about one shortcut that it is well required to convert kilometer per hour into meter per second. And one more thing I ensured you during that in 90% of the questions the speed will be given in a multiple of 18. And that's given in multiple of 18. Even the final is given in multiple of 18. So U is this. So convert this into meter per second. So 18 into 5 upon 18. 18 and 18 gets cancelled out. So this will be 5 meter per second. This is the initial velocity. And when it accelerates, oh, the speed is increasing. So final velocity is how much? That is 36 kilometer per hour. So 36 into 5 upon 18. 18 to the 36 and 2 5 are 10. 10 meter per second is the final velocity and this is denoted by V. Initial is denoted by U, final is denoted by V. And what is the time taken for that? That is 10 seconds. Time is already given in the convenient unit 10 seconds. So apply the formula for acceleration. Acceleration A is equal to change in velocity v minus u upon time taken t. So v minus u, final velocity 10 minus initial 5 upon what is the time taken? 10 seconds. So 10 minus 5, this will be 5 upon 10. So this will be 0.5. The unit for acceleration is meter per second square. Remember, don't forget to write the unit. That's the trouble the students create while solving the numerical that they don't write the unit. So you should mention the unit and take it in your mind. Okay. Now students, we will solve few more numericals. Numericals are quite similar to this numerical. So we are going to solve another numerical which will be different. So a car attains car attains a velocity of 36 km per hour after accelerating after accelerating uniformly from rest in 5 seconds. Find the distance traveled. So students, this is the question given to us. Let us imagine the picture of this. The car attains a velocity of 36 km per hour after accelerating uniformly from rest. So the initially the car was having zero velocity because it was in rest. So initial velocity of car, initial velocity u, that is zero. And in which unit we should imagine? In meter per second. Okay. And what is the final velocity acquired by the car? 36 km per hour. So final velocity, that is V, 36 km per hour. In kilometer per hour, this is 36. So in meter per second, how to convert this? Multiplied by 5 upon 80. This you have to remember. So 80 to the 36, 2 5 the 10. 10 meter per second is the final velocity. Fine. So in 5 seconds, what is the time taken? Time taken is 5 seconds. So they are asking for distance traveled. Which equation of motion we should apply here? So for distance we can use this equation S is equal to ut plus half AT square. Which equation is this? This is second equation of motion. Second equation of motion. All the terms are given to us for applying. U is given, time will be already that is given to us. 5 seconds. Acceleration will be required here for solving it out. So we can calculate the acceleration. No worry for that. What is the formula for acceleration? Acceleration A is equal to change in velocity v minus u upon time taken t. So this will be final velocity is 10, initial is 0 upon what is the time taken? Time taken is 5 seconds. So 10 minus 0 upon 5, so 10 upon 5. This will be 2 meter per second square. So this is the acceleration. So acceleration is now known to us. U and V are given to us. Time is given to us. So proper things are given to us. Even we can use V square is equal to U square plus 2as. That is third equation of motion. By using that also you can calculate the value of x. Right now I am going to apply second equation of motion. So it's up to your choice. You can apply anyone among these two. Okay. So u, what is u? 0. 0 into time. Time is how much? 5 seconds. So 0 into 5 plus half into acceleration is how much? 2 into what is the time square? That is 5 square. So this all term is 0 plus 2 and 2 gets cancelled out. 5 square is 25. So this will be 25 meters. That is going to be the distance traveled and the answer. I hope you understood this. Even all the numericals which we have discussed on today. And keep on solving the numericals, practicing the numericals from NCERT and solve it on your any notebook or somewhere else. So thank you. God bless.